This is lesson 2.6, Solving Absolute Value Inequalities. The essential question here is, how can you solve an absolute value inequality? So what we're going to look here is that an absolute value inequality is an inequality that contains an absolute value expression. For example, the absolute value of x is less than 2, and the absolute value of x is greater than 2, are absolute value inequalities. Now recall that the absolute value of x equals 2 means that the distance between x and 0 is 2. So the inequality of the absolute value of x is less than 2 means that the distance between x and 0 is less than 2. So we put an open circle at 2 and negative 2, and it's the line in between those two. It could be any of those. Now, for the inequality of the absolute value of x is greater than 2, it means the distance between x and 0 is greater than 2. So we put the open circle again on 2 and negative 2, but this time, instead of being the line between, it's the lines going out the other directions. So our core concept right here is that solving absolute value inequalities. So to solve the absolute value of ax plus b is less than c, for anything where c is greater than 0, you're going to solve the compound inequality of ax plus b is greater than negative c and ax plus b is less than c. When it is the inequality is greater than c, or c is greater than 0, it's going to be the or. So in the inequalities above, you can replace the less than with less than or equal to, or the greater than with greater than or equal to. So let's look at an example here. Solving an absolute value inequality. Solve each inequality and then graph the solution if possible. So with A here, we're going to have the x plus 7 is greater than or equal to my negative 2, and x plus 7 is less than or equal to my positive 2. So to solve this, I need to subtract 7 from both sides. So x is greater than or equal to a negative 9. And we'll subtract 7 from this side. So x is less than or equal to a negative 5. And remember, this is that and. Remember before I said that the and would be a line in between the two circles. So let's just say that this right here is negative 5. So this is 6, 7, 8, 9. So this is negative 9 right there. And it is going to be solid circles since they are equal to it. And it's going to be everything in between there, the two circles connected. So let's see, what about this other one? Just kind of draw a line here. And for this one, it's telling us that by definition, the absolute value of an expression must be greater than or equal to 0. So an absolute value expression right here could never be equal to, cannot be less than 0. Because it wouldn't matter what number I put in for x, nothing can be less than 0 and be an absolute value. That cannot be true. So there is no solution to part B. Because always remember, an absolute value sign, if you get the absolute value by itself, can never be less than 0. So let's look at example 2 now. Solve each inequality and graph the solutions. I have A right here. So c minus 1 is greater than 5. So remember, when we're doing that, it's c minus 1 is less than or equal to negative 5, or, remember, it's an or because it's less than 0, negative 5 is less than 0. We have c minus 1 is greater than or equal to 5. So to solve this, we're just going to add 1 to both sides. So C is less than or equal to a negative 4, or add 1, C is greater than or equal to 6. So if I say this is negative 4 right here, we'll put a solid circle because it has the equal sign. Let's see, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6 is right here. It's again a solid circle, but it's going to be, since it's an or, it's going away from each other, not towards each other. Everything less than negative 4 or greater than 6. It's right there, 0. Let's look at part B. Solve each inequality and graph the solution. Okay, again, this is, the negative 2 is less than 0. So, by definition, the absolute value of an expression must be greater than or equal to 0. So the expression of the absolute value of 10 minus m will always be greater than negative 2, because this is always going to be a positive number. The absolute value is always going to be a positive number, so it's always going to be greater than a negative 2. So it's going to be all real numbers. So you just draw an arrow going all over the numbers. I mean, I'll just put a 0 there just to signify that's where the 0 is. But it's all real numbers. So let's look at C. The first thing we need to do is remember to isolate the absolute value expression. So the first thing I need to do here is get rid of what's added or subtracted to the absolute value expression. So we're going to subtract 1. So we get 4 times the absolute value of 2x minus 5 is greater than 20. Now, we still have this 4 outside, so we need to divide by 4. So I have the absolute value of 2x minus 5 is greater than 5. So now, we're going to have an or statement. So we have 2x minus 5 is less than negative 5. And then we have or 2x minus 5 is going to be greater than 5. So to solve this, the first thing I need to do is add 5 to each side. So 2x is going to be less than 0. Divide by 2, those cancel out, and x is still less than 0. Or, we add 5 to each side. Sorry, I'm kind of running out of room here. We get 2x is greater than, remember that was a 5, so I've got 5 plus 5, which is 10. And then I need to divide by 2, and x is greater than 5. So, x is less than 0, or x is greater than 5. So x is less than 0, so here's 0. It doesn't have a line underneath, so it's going to be an open circle, and less than x is going this way. Or x is greater than 5. Let's see, 1, 2, 3, 4, 5's right here. So again, an open circle, and x has to be greater than 5, so it's going this way. That's how you would solve and graph that inequality. So now we're going to be looking at modeling with mathematics. You're buying a new computer. The table shows the prices of computers in a store advertisement. You're willing to pay the mean price, remember mean is average, the mean price with an absolute deviation of at most $100. How many of the computer prices meet your condition? Well, first you need to know what an absolute deviation is. An absolute deviation of a number, x, from a given value, is the absolute value of the difference of x and the given value. I know that's still maybe a little confusing, so let's just kind of walk through it so that you understand what I'm talking about. So, to understand the problem, you know the prices of 10 computers. You are asked to find how many computers are at most $100 from the mean price. That means you could be $100 more than the mean or $100 less than the mean. That's what the $100 deviation is meaning. So we're going to make a plan. So what we're going to do is calculate the mean price by dividing the sum of the prices by the number of prices. So, then we're going to use the absolute deviation and the mean price to write an absolute value inequality, and then solve it. So, if I were to add all of these numbers together that are in this chart right here, I would get 6,640. And then you're going to take that and divide, which is 10 computers. And that is going to be equal to $664. Now, we're going to let X represent the price you're willing to pay. So the absolute value of X, the amount you're willing to pay, minus 664 has to be less than or equal to that $100 you're willing to pay the difference of. So what this is really saying is that it's going to be negative 100 is going to be less than or equal to your X minus 664, which is going to be less than or equal to a positive 100. So then to find out and solve this, you're going to add 664. But unlike an equality, you have to add it to all sides. So we're going to add it on both sides of the inequality. So this is going to be 564 is less than or equal to X, which is less than or equal to 764. So you're willing to pay between 564 and 764. And if you look here, this one's too high, so that one's out. 650, that's good. 660, that's good. 450, nope, it's too low. 725, that's good. 750, we're willing to pay that. 370, nope, that's too low, must be a cheap computer. 670, we're good. 650, we're good. 825's too expensive. So we're willing to buy 6 of the computers. So 6 of the computers are in that price range. Show me your notes and get started on your clever assignment.